We now want to look at the first of methods. There's 3 different methods. It's the first of those methods that we are going to look at that you need to solve for your assessment. So this one is called a minimum cost spanning tree. Let's have a look. So just a quick reminder first of all about trees. Remember, what is a tree? So think about your branches. Each of the branches is an arc. There's one pathway between every node. Specifically, there are no loops, there are no circuits. That's really important. So a spanning tree is where all of the nodes are connected together. So I could just have a tree which is a part network, but a spanning tree means it spans everything. Okay, all of the nodes are spanned. So here's a network, A, B, C, D, E, F. We're just going to make a spanning tree from this network so that we can understand what it is. I'm going to start with, there's an arc between node A and B. I'm going to add in the arc between node B and C, then an arc between C and D, between D and E, and between E and F. And I've taken the rest of the network away, so now you can see that is a spanning tree. There is a pathway from every node to each other, but there aren't any extra arcs in there. And it involves all nodes in the solution, so that's what makes it a spanning tree, not just a tree. Let's have a look at the same network again and see if we can make a different spanning tree. So I'm going to start with that arc between A and B, and then I'm going to add the arc between B and F. Then I'll add B and C and E, and C and D. So that is another spanning tree. With the same network, I've got all of the nodes in the solution, and that is an example of a spanning tree rather than just a tree. So with a network, you could make lots of different spanning trees. And the problem that we're trying to solve, a minimum cost spanning tree, is to find which of all of these spanning trees has the smallest number, or the smallest amount of money, smallest amount of cost, small amount of distance, smallest time, whatever our arc weights or our units are that we're trying to find. So that's what that is. We want to find the best solution. So there's several ways that we could do this. We could just do it with trial and error and draw up every single possible network diagram that you could have, spanning tree you could have, and then work out the cost of all of them, and then figure out which one's the best. The one method in the book that they use is to have all of the network drawn and then to take away the longest edges. And you can use that. I'm quite happy for you to use that. My personal preference though is to use Kruskal's algorithm, and he's just the name of the person that designed this. And I find personally that this is a much easier algorithm to do because you need to start with nothing and you're going to only add on a few arcs. Okay. So the important thing about Kruskal's algorithm is it is guaranteed to give us the best solution, and that's what we want. Okay, that's part of what this standard is about, is being able to come up with the best solution. In the assessment, if you don't give me the best solution, I cannot give you credit for that answer. It has to be the best solution, and this method gives us that. So we're going to start with this very, very important idea. If there are n nodes in my graph, then I'm going to need n take away 1 arcs in your spanning tree. Okay, and so let me just go back to this one for example. So if we look at this, nodes A, B, C, D, E, F, there's 6 different nodes in that network. Okay, so in my spanning tree I need to have 6 take away 1, which means 5 arcs, and you'll notice there that I've got 5 arcs. I've got 1 arc that goes between A and B, that's arc 1. Here's arc 2 between B and F, arc 3 between B and C, arc 4 between C and E, and arc 5 between C and D. And the previous spanning tree that we had also has 5 arcs. Okay, so this is a really important thing. The number of nodes, take away 1, tells you how many arcs you want to have in your spanning tree. Okay, so let's just go forward to... So this is the algorithm. So first step, work out how many arcs you've got, or how many arcs you need in your solution. Then the second step is to choose the shortest one, choose the smallest number. Step 3 is to choose the next shortest. So what's the next second smallest number? And you're going to keep choosing that smallest number until you've got enough arcs, until all the nodes are connected. And the only thing you need to double check is every time you add an arc in, you've got to check, does it form a cycle or a circuit? Because if it does, then we can't add it. Okay, that's the only thing we've got to be careful about. So let me just go through and show you how this one works. So here's our example. Telecoms is rolling out their fast broadband, and they've got to lay some cables to connect some farms together. Okay, the weights of the edges are the length of cabling that would be required, and the problem that we need to solve, we want to find what is the minimum length of cabling needed to connect all the farms. So these are some of the key things that tell us that it's a minimum cost spanning tree problem. It asks for the minimum length, and it wants us to connect all of the nodes together. So those are the two really important things to look for that tell us this is a minimum cost spanning tree problem. So here's our farms. All right, and we've got roads that go between them, and remember the distance on there, so all the numbers on the arcs represent the amount of cabling that would be required to connect these different farms together. So the first thing I do, step 1, is to find out how many arcs do I need in my solution. Okay, so let's go back here, A, B, C, D, E, F. That is 6 different nodes. So if I've got 6 different nodes, then I'm going to take one away from that, and that tells me I need to have 5 arcs in our spanning tree. Okay, so step 2 says choose the shortest edge. So I look at all of the numbers on there, and there is my smallest at 2 kilometers. So I'm going to draw that arc in, and this is where I would, with my highlighter, go over and highlight that arc and say, right, this is what I'm going to keep. So I'm going to keep the arc between node D and E, because it's the smallest edge. Now I've got 1 arc in my solution, and remember, I'm going to keep adding them until I've got 5 arcs. Now step 3, now I've got to choose the next shortest edge. So now I look at all the other numbers and think, right, which one's the next smallest number? And it's this 3 kilometers over here between nodes A and B. So that means I'm going to add that arc into my spanning tree solution. Okay, now I've got 2 arcs in my solution, so I'm going to keep going because I'm not up to 5 yet. Now step 4, I'm going to choose the next shortest edge. So I look at my network and say, right, what's the next smallest number? And I've actually got 2 arcs that are both the same distance. So I've got 1 arc here between A and E, which is 4 kilometers, and I've got 1 arc here between C and D, which is also 4 kilometers. So it doesn't matter, because these have got the same distance of 4 kilometers, it doesn't matter which one I choose first, because I'm going to choose the other one after this. Okay, so I'm just going to randomly choose the arc between A and E. Okay, and I'm going to add that one in, and I'm going to remember to keep an eye on that 4 kilometers there, because that will happen in my next step in the process. So I've added in the arc now between A and E, and that now gives me 3 arcs in my solution. So I've got to keep going. I'm going to repeat this step again. I'm going to choose the next shortest edge, and so there's my other 4 kilometers. So I'm going to add that arc between C and D. And so now I've got 4 arcs in my solution, and I stop when I get to 5. So at the moment I've only got 4, so I need to keep going. I need to get 1 more, so 1 more step through. So now I'm going to look at the shortest edges, and there are 2 possible ones there. One is between B and C at 5 kilometers, and the other is between E and F at 5 kilometers. Now this is where I've got to check something carefully. If I was to add that arc between B and C, can you see what would have happened? So between B and C there, if I add that arc there in, all of a sudden I could travel around this whole system in a big circuit. Yep. I can't get to node F though. Alright, but there is a circuit there. So that means I am not allowed to choose that arc. I cannot choose the arc between B and C because it would make a circuit. And that's what I want you to do on your, in terms of your working, is I just want you to show me, look, I can't do this arc, and put a big cross through it, and that shows me that you've gone through that process and understand the algorithm. So that means I need to add this arc between E and F, that's 5 kilometers. Okay, that now gives me 5 arcs in our solution, so now this is where I'm going to stop. Okay, so when I write my solution, I need to draw the spanning tree graph, and I need to work out what the minimum total weight of that is. So in our case, we needed to find, so there's our network diagram, so that tells the company that they need to lay cabling along these between these different farms here, and that the amount of cabling that they need in total, the smallest possible amount of cabling they're going to need, is 18 kilometers worth of cabling, and that will then connect all those 5 farms together, and they will all have fast broadband. So what you need to do now is go to exercise C, which is on page 14, and I want you to answer all of those questions. If you're aiming for a merit or excellence, you need to complete this exercise in 1 lesson, because we need more time for other algorithms. If you're aiming for an achieved, then you can spend up to 2 lessons on this, but no more than that.